we've been solving quadratic equations for a while now, right? There's different methods of solving quadratic equations. There's factoring, setting it equal to 0, factoring, splitting, and solving. There's completing the square. There's taking the square root to get rid of a square. And last week we did completing the square to derive the quadratic formula. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. You just need to memorize it, okay? There are some teachers that have like a little story to it. Oh, there was a negative b that was invited to a party. She didn't know if she wanted to go. Whatever. Forget that. Just memorize it. If you want to memorize it with the story, great. But you got to memorize it. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. See, I can say it without even thinking about it. Right. Negativo b más menos raíz cuadrada de b cuadrado menos 4ac dividido por 2a. What? I don't know. It just comes out of me, right? That was in Spanish. So you need to memorize this. Negative b plus or minus square root of b squared minus 4ac all divided by 2 times a. Now, what the heck does that mean? This is the formula that will give you the answer. X equals. This will be the answer right here of any quadratic equation that's in standard form. If you have a x squared plus bx plus c equals 0 and they ask you to solve it, all you got to do is take your a value, your b value, and your c value and plug them into the a's, into the b's, and into the c, and then do the math, and it'll give you the answer instantly without having to complete the square or factor or any of that other stuff, right? So the key to it is to, let me move this out of the way. The key to it is when you use the formula, you should use it by rewriting everything, but instead of the letters, you write parentheses, okay? And then you identify your A, B, and C values, and then you plug them into the parentheses. Okay, so keep this in mind. You need to start by rewriting the whole thing with parentheses in each spot that you're going to plug in the A, B, and C values. If we take a look at page 264 in our books, the very first thing that we see here is what we did last week, where you have a regular standard form equation and they derive the quadratic formula by completing the square. I don't know if you guys remember that. We divided everything by a, right? So that ended up being 1. Here's a divided by a, 0 divided by a is still a. And you could look through that on your own if you want to remind or refresh your memory on how to how to derive the quadratic formula by completing the square. That's not that important. Let's move on. So let's actually go to example 1 in our books, and we'll see right here it says solve x squared minus 10x equals 11 by using the quadratic formula. Okay? So do we have to use the quadratic formula? No. Will the quadratic formula work? Yes, it'll always work, right? Now, in this case, it probably wouldn't be the best idea to use the quadratic formula. Why is that? Because when you subtract 11 and set it equal to 0, you're going to have x squared minus 10x, minus 11 equals 0. Okay, and that is a quadratic trinomial equation. And could we factor this? Could we think what times what is negative 11, that if I add together is negative 10? What two numbers would that be? Negative 11 and positive 10, right? I mean positive 1, right? Sorry. Okay, so we factored it. It is equal to 0, so we're able to split it. Let me move this over here to the side. So if I split it, it'll be x minus, give me a second. Can't erase it. Okay, let me just scribble it out then. Okay, so I'm going to have x minus 11 equals 0. And we know that that answer is going to be x equals 11. And we also have x plus 1 equals 0. And that answer is going to be x equals negative 1. So we have our two answers. We're done. Yeah? However, factoring will not always work. Okay? And whenever all else fails, you could always fall back on the quadratic formula. So it's a good idea to look through this example 1, and we'll see that we'll get the same exact two answers, 11 and negative 1. However, let's go through the steps. Now, it says that you need to make sure that the equation is in standard form, right? Right here, ax squared plus bx plus c equals 0. And, of course, it is written in standard form. I mean, once you move the 11 over. So first step would be to get this 11 and move it over. And then you'll have the quadratic trinomial equation that you have here in standard form. The only thing that I notice is probably wrong with what the book is explaining here is, you guys see this black minus sign? It should be green because the 11 is green. In other words, the C value is negative 11. The B value is negative 10, so that should be a blue minus sign also, and the A value is a red positive 1 right there. Okay, so all you do to use a quadratic formula is first know the quadratic formula, here it is, and then plug it in. Okay, so notice the B's are in blue, so they plug in the negative 10 with parentheses. Remember I said always start this with parentheses. And here's another negative 10. And then you have the A value, which is 1, the C value, which is negative 11, and the A value, which is positive 1. And now, the trick to simplifying a quadratic equation expression after you plug in your values is that you have to start with the inside of the radical, which is also known as the radicand value. Okay, the radicand. Or, in this case, it's also known as a discriminant, which we're going to be talking about this week. So this inside value is called the discriminant, and you always start with the inside value. So it's kind of like if you zoom in and ignore everything else and think about what would you do first? Square, subtraction, multiplication, or multiplication? What do you do first? Square, right? So when you square negative 10, what do you get? Negative 10 times negative 10. 100. Okay. So you're going to end up with 100 right here. And then I'm not going to subtract. You can't subtract. You subtract at the very end. All right, so we did exponents. Let's do the multiplication here, and then we'll subtract at the very end. Now, of course, you could call this a negative 4 if you want. I'll just leave it as a minus sign. So what's 4 times 1? 4. And what's 4 times negative 11? Negative 44. So if you think about this, you have this minus sign, just to do it on the side, and you have a negative 44, and of course, that's going to change to a plus plus, okay? So it's really going to be the 100 that you have right here plus 44. Does that make sense? Okay. Now, like I said, if you wanted to, you could go back to this minus sign, and you could call it a negative 4 if you want, which I would probably do that. Negative 4 times 1 is negative 4, times negative 11 is positive 44. But remember, that was a minus sign, so you have to put the plus sign in front of the 44. Depends how you feel more comfortable. Anyhow, you start by doing the discriminant, or the discriminant value, and we still need to finish that. The 100 plus 44 is 144, and luckily you could take the square root of 144, which is 12. And remember, if you have a bunch of numbers, you have to do both situations. You do the 10 plus 12 and the 10 minus 12. And they write both situations down here. They go 10 plus 12, that's 22, divided by 2, the answer is 11. Or 10 minus 12, that's negative 2, and negative 2 divided by 2 is negative 1. That's another answer. So the solutions are negative 1 and 11. Sometimes, right here, it doesn't work out so beautifully. Sometimes you have something that you can't take the square root of. Like right here, the square root of 144 is 12. That works out great. Sometimes you end up with like a 13 right here, which I think is even easier. Because if you have the square root of 13, you can't simplify it. So you're done, right? But then again, sometimes you might end up with the square root of 20, and that you could break down. You can't get rid of the square root, but you could break it down to 4 times 5, and you need to be able to simplify. So I guess the only difficult part of using the quadratic formula is being good at simplifying, right? Which is really not that difficult at all. Let's move on. So on this example, I already factored it, split it, and solved it, right? The book does it with the quadratic formula, because that's this section, practicing the quadratic formula. So they identify their A, which is 1, their B, which is 8, and their C, which is 16. And they plug it into the B's, to the A's, and to the C. And they work it out on this example. But as you can see, you could factor and then split them and solve, and you get your two answers, which is really one answer, x equals -4. Now, what does that mean that you found the answer, -4? Remember, we've been saying this for a while. The answers are really the solutions. The solutions are really the x-intercepts. They're the roots. You guys remember that paper that's on the wall over there? It says answers, x-intercepts, solutions, roots. It's all the same thing. Yes? Okay? So if I were to think about the graph of this quadratic trinomial, this function, if I were to get a graphing calculator and type in y equals x squared plus 8x plus 16, and if I were to hit graph, what would my answer be? My answer is going to be -4. What does that mean visually on a graph? It means that when you look at that graph, it's going to cross the x-axis where? At -4. And as you can see, here it is graphed on your books. It shows you that it crosses at -4. Okay? So we need to keep that in mind, that the solutions are really x-intercepts values, especially for the next section when we're actually transforming parabolas and dealing with vertex form. So let's move on to the next one. Here's another example. Now on this one, guys, do we have to use the quadratic formula? Could you factor this? Like if I were to go plus 10, I could have x squared minus 6x plus 10 equals 0. Now could I think, let me move this up a little. Could I think what times what is 10 that if I add together is -6? What times what is 10? It's 5 times 2 or 10 times 1. If I add those, do I get -6? No, guys, this is not factorable. So right here, I mean, factoring is nice, but it's not the solution. I mean, it's not the answer to all your questions, right? This does not work. Factoring does not work, right? So right here, you're faced with two choices, either completing the square or quadratic formula, okay? If you want the quadratic formula, you still need to take this -10 and move it over to the other side by adding 10 to both sides. That way you could see that your C value is +10, the way they do it in the book, okay? Now they do it in the book right here. They show you all the steps and they simplify. Just to walk you through it, -6 squared, that's 36. -4 times 1 times 10, that's -40. So -36 and -40, I'm sorry, +36 and -40 is -4. And we know that when you take the square root of a negative, you end up with imaginary. So if I tell you what's the answer, where does it cross the x-axis? What's the x-intercept? It's not a real x-intercept, it's imaginary. What does that mean visually? It means that it doesn't cross the x-axis at all. Cool? So right here you need to use the quadratic formula, or you could complete the square and solve. So we had a good question right here. Why is the final answer 3 plus or minus I? When we're simplifying, yeah, we know that the square root of -4 is 2i, and the plus or minus is in the formula, so you really have 6 plus or minus 2i over 2. Now, if this were a 5, I would leave it like that, yeah? But because it's a 2, and each of these guys are divisible by 2, it's a good idea to take that 2 and to split them into each one, right? So it's a good idea to say 6 over 2 plus or minus 2 over 2 with an I. It's a good idea to take that denominator 2 and to split them. Why? Because 6 is divisible by 2 and 2 is divisible by 2. Like I said, if it were a 5, I would just circle it and leave it like that. Okay? Because neither of them are divisible by 5. So if you divide, 6 divided by 2, you get the 3. 2 divided by 2, you get 1. You don't even need to write the 1. That's your final answer right there.